Hello, this is Michael, and I'm going to be doing the stage 3 of standard 4. Um, and in standard 4, the problem says infinite many sectors can be cut from a circular piece of paper with the 12 cm radius, and with any sectors and can be fashioned into a paper cone with 12 cm slant height. So what this means is what I'm going to show over here. So first, I'm going to read part A as to show the volume of the cone produced by the 180-degree sector is larger than the volume of the cone produced by the 120-degree sector. So move over here. What I did first is I drew these graphs to help me visualize things. So basically, in order to compare the 180 degree sector's volume to the 120 degree sector's volume is volume. So we need to find volume for both of these sectors when they're created into cones. So first, in order to find the volume of a cone, I need to find the height of the cone. So for the 180 degree sector, I found the arc length by doing proportions. So it's going to be 2 pi times 12 times 180 over 360. So what I did here is 180 over 360 is how many is the proportion of the arc length to 360 degrees, and this is how we find circumference. And coincidentally, this is just a semicircle, so basically it's the circumference divided by 2. So now we have found the arc length. This is going to be the base of our cone. So then I need to find the radius of the base of the cone, which can be found by doing 37.69 is equal to 2 pi r, as I've written down right here, and r is 6, as we found by doing using our calculators. Then use the newfound r, which we have acquired just now, and the slant height, which is 12, which is given in the problem, to find the height by Pythagorean theorem. So basically what we're trying to find is this right here, and we already know this and this, and we know this. The x right here is r, the newfound r, which is 6. So what we can do is 6 squared plus y squared is 12 squared, and y will be equal to square root of 108. So with all these status, I used the volume formula to find the volume, which is right here. So it's going to be, for the 180 cone, it's going to be 1/3 of pi times radius squared, which is 6, as we found in the problem. 6 squared times the height, which is square root of 108. So by doing that, we found the volume to be 391.781 centimeter cubed. So then moving on to the 120 cone. So for the 120 cone, just to save time here, we're going to do the exact same thing as we did for 180. And if you follow the steps that I just showed you for 180, you should get the volume by doing 1/3 of pi times 4 squared times square root of 128, and you're going to get the volume to be 189.563 centimeter cubed. So now they're boasting their volumes, we can compare, and it is true, as it says in part A, that the volume produced by the 180 sector is greater than the volume created by the 120 degree sector. So that is true. So now for part B, okay, I'm gonna jump jump a little bit around here, but I'll make sure we hit all the parts. So for part B, we're actually gonna skip that and come back just for a better better assumption or a better prediction. So so we're gonna do part C first and find the equation for the volume of the cone as the central angle theta of the sector used to form it. So going back to part C, we're gonna do this first, and we're gonna go back to that. So part C, we can use a lot of the information that we found in part A and apply that knowledge to here, but for part C, we're just gonna replace the actual numbers into variables. So what we're gonna do is for the volume of the cone is we need to find the base, and in order to have a function for the base, I'm gonna have to find the radius of the cone, which can be found by doing 2 pi times 12 times x over 360 over 2 pi, which can be simplified down to 12x over 360 is pi. So this is r, pardon me. So this is how we're gonna find the r of the base of the new cone. And for the height, we're gonna do 12 squared, which is not gonna change for this problem, is equal to 12x over 360 squared plus y squared. So y is going to be the height, as you have seen here. So basically, we're just taking all this and replacing them with variables. So y is going to be this. So I'm going to combine these two equations into one jumble one. So it's going to be 1/3 pi times 12 times 180 over 360 squared times square root of 12 squared minus in parentheses 12 times 180 over 360 parentheses squared in the square root is equal to and this is our equation, which is right here. I skipped ahead one step to the 180. So this is how we use to prove that the equation is actually right, which we found it works. So this number is the exact same as we proven before. So now we did the same for 120, and I used a calculator to find it, and it's the exact same thing. So we can prove that it is right. And for part D, we're asked to find the domain. So domain of V, it has to be the theta has to be greater than 0 and less than 360 for the cone can be accurately measured with this function after 360, and it can be less than 0. And for part E, determine and sketch the sector that produces the cone of the greatest volume. So I used a graph on my calculator to graph the function in order to find the maximum. That's just how I learned it. It's easier for me to see what the maximum is going to be. To save time, I already punched in the equation and set the right window settings. So now all we have to do is do menu, analyze graph, and we're going to do maximum here, and we're going to just see what the maximum is going to be. So the maximum of this graph is going to be 294. So our answer for theta is going to be 294, and it's going to look something like this. And when turned to the cone, it's going to have the greatest volume. So going back to B, so E basically answers D. I was just basically a little clueless to find B, so I just skipped ahead. But the greatest volume is adequate answer for part B. Thank you.